Welcome to Lesson 20. More factoring. We're going to do something called factoring by grouping. This will be our final kind of factoring for this little set of lessons that we're doing here. I have to show you this one, and I guess I can best explain when we get to the end of the lesson why I have to show you this one. Anyway, it's a good one to know because, as you might see here, it's a nice way to factor four-term expressions. So when we have four terms, this is going to be the thing that we usually try. Now, actually, I should point out first that down here in the course description, you can print out the guided notes, which is actually what you're looking at here. This is a PDF file of what I'm about to lecture on. You can also, below there, you will see the homework set. It's 10 problems, 6 here, 4 here, and that gets turned into the D2L lockbox, drop box. And then here's the lecture that I started to start, and then I realized I wasn't showing it on the screen. So here we go. We're going to start the lecture officially now. So factor by grouping is something I got to show you because it's a nice way to factor four-term expressions like this. So when you get four terms, and notice none of these are like terms, right? I've got an x cubed, I got an x squared, those don't mix. I got an x, regular x, those don't mix. And I got a constant, those don't mix. None of those are like terms, so you are indeed stuck with a four-term expression there. When you have a situation like that, that's when we're going to try this factor by grouping thing. Okay, so let's back up to these two up here. I want to show you the basic idea behind how it works. So I'm looking at this xy plus 5y, and I wanted to show you this first because in my experience, hardly anybody ever hesitates when I show them this one. I say, hey, how would you factor that? And they're like, well, you know what? The very first kind of factoring we learned, remember, was to pull out common factors. And if you look, we do have two terms, this plus this. So we're looking at two separate terms. And both of these terms contain something in common there. They both have a y in them. Both terms contain a common factor of y, is how we'd say that. And so you say, well, I can basically undistribute. I can pull the y to the front, leaving me with x plus 5. Because if I distribute, I'd have yx, which of course is the same as xy, and then I'd have plus 5y. So it works. It works like a charm. Okay, you just pull that y out to the front. Now, come over here and look at this one. How is that one different? Well, at first glance, it's very different, right? It looks a lot longer, doesn't have any y's in it. It's got all this extra x stuff going on. It's like, whoa, it looks so different. But is it really so different? I mean, what do we got? Looking back at this one, we had x times a thing. I'm just going to say it's a thing. And I had plus 5 times a thing. Just call it a thing. Okay, it's just a thing. Over here, I've got, see if you have deja vu. I have x times a thing, plus I have 5 times the same thing. Huh? It's the same pattern is the point. This is two terms. Come on, you. Come on, you. This is two terms which share a common factor. The factor in this case is a bigger factor. It's an x plus 1 in parentheses factor, but it's a factor. Just like this original one had a common factor of y in both terms, over here we have a common factor of x plus 1 in both terms. So what you can do then is you can, what did we do here? We pulled out the y. What are we going to do here? We're going to pull out the x plus 1 because that's the common factor. And then you go saying, well, if you think of this as a thing, x plus 1 times what will give me this term? X plus 1 times x would give me that term, right? X plus 1 times what would give me this term? X plus 1 times 5 would give me this term. And I know it looks goofy. We've never really done this before with factors that were so big looking before. But the point I'm trying to make is that, again, when I show people this one and I say, hey, factor, pull out a common factor, there's no hesitation. Yeah, the common factor is y. I'm going to pull that out. When I say factor this, people tend to always hesitate for at least the first few times around. They're like, what do you mean? It looks bigger. What do you mean? It doesn't look the same. But it is. It is the same form, at least. It's the same form. And it's the basis. Oops. Go take the y out, do we? It's the basis of this thing called factoring by grouping. Okay, so I invite you to kind of stare at this for a while, you know, think about it, chew on it, ruminate a little bit until you start to say, oh, I see what's going on. Here we had x times a thing plus y times the same thing, so we pulled the y out. Here we had x times a thing plus 5 times the same thing, so we pulled that same thing out, and we were left with the x plus 5. Looks goofy, I know, but it's the basis of this whole method. All right, so let's put this to work now. I've got two key examples that will get the idea of factoring by grouping across, I believe. So the first one, come on you, come on you, come on you. Okay, you. I got 4 terms. Remember, this is when we try the factor by grouping. The first thing is to group them, actually. Make groups of 2. Take the first 2 terms and kind of group them in a parentheses like this. Plus, group the last 2 terms and put a parentheses, something like this. Okay, that's the grouping part of factoring by grouping. Now, something I want to emphasize here, actually, is the way that I have this big old plus here, right? The plus, come on you, the plus separates the parentheses, right? It separates the groups. The groups are added by addition. These 2 groups are added to each other. And it's important to point this out because what a lot of times I'll see people do is they'll just say, I want to put parentheses on here. Here I go. And it's like, well, wait a second. You just made a boo-boo, and I'm going to have to deduct a point for that, even if you get the right answer in the end, because you did something you should not have done. You made this look like a FOIL problem. It's not a FOIL problem. If you really had these parentheses like this is telling the reader to multiply the x cubed times the 3x and the x cubed times the 6 and then the 2x squared times the 3x. Okay, this is not a foiling problem that we have here at all. It's not a foiling problem at all. So somehow I need you to write down, don't do it that way. Don't do it that way. There's this big old plus in the middle that's keeping it separate. This really is an addition problem. And notice that if you were to get rid of this plus, I mean, what would you do? It's kind of like having a plus 1 in front, right? You'd have this x cubed plus this 2x squared, and then you'd have 1 times 3x would give you the 3x, and then you'd have 1 times 6 would give you the 6. See, that's exactly that's exactly equivalent to what we started with. Come on, you. I got it, so we'll get used to. What are you doing to me now? You're an eraser. It's an eraser. It's not supposed to do anything to me. So let me just take this all out so it doesn't look quite as messed up. Anyway, that's much ado about step 1, the grouping part. Once you've grouped, here's where the magic will start to happen. You look at the first group and you say, pull out a common factor from there. Notice both of these terms, the x cubed and the 2x squared, both have x squareds in them. So you'd pull that out, and that would leave you with an x plus a 2 plus. Then you come over to the next group, and you say, I got a 3x and a 6. Well, those both have 3's in them. So I'm going to pull the 3 out and have an x plus 2. And then you're happy. You're happy because it worked. See? I got a thing, and then I got the same thing. I got a thing and then the same thing. That's how you know it's working. And so then you can take that thing, called the x plus 2 really, and undistribute it. Pull it to the front, leaving behind. Again, I've pulled out the x plus 2. I've pulled this out. Notice what my leftovers are here. Now let's do it this color here. Come on, you. Okay, my leftovers are x squared. So I put the x squared here, plus, and then I have another leftover, which is a 3. And then this would be my answer. That would be my answer right there. Okay, so just based on how much I've written down, I guess it's not that much of a long problem. It's just that every single step, of course, might be a new step to you. So you have to kind of, you have to talk yourself into why this is working. And yes, I can do this. And yes, I can do this. You have to convince yourself that every move is a legal move, and so on. You have to believe what you're writing. That's the only way to get anywhere in math, is make sure you believe every single thing that you write. So on that note, let's see if you'll accept my challenge here. This problem here, well, if you use this as your template, you should be able to get that problem done yourself. So I'm going to invite you to pause the video and then try this problem yourself. Pause. Unpause. Okay, the first thing I'm going to do is I'm just going to do the grouping thing. 2x cubed minus 4x squared. These groups are separated by a big old plus, like this. Okay, make sure you show that big old plus like that. Now I look at the first group and I say, from both of these terms, I could pull out a 2x squared, actually. So I'll pull out a 2x squared, leaving me with an x minus a 2. Put my plus down there. Then I look at these two terms and I say, well, I could pull a 5 out of both of those, leaving an x minus a 2. And then notice we have a matching factor here. And so this is the part where you smile, because it means that factoring by grouping is working. It's not always going to work. It's not like you can take any 4 terms, throw them down, and factor them by grouping. It doesn't always work. The terms have to be kind of a special case for it to work. But you'll know it's working when you get to this point. You say, I've done the grouping, I pulled something out of each group, and look what I got there. I got me the same thing, an x minus 2 in both of these. So I can pull that to the front now, pull the x minus 2 to the front now. Maybe I'll keep it green, just make it easier to follow on the eyeballs. Leaving behind a 2x squared plus a 5. And that's the name of that tune. What do you say one time we kind of prove that this is really working? Let's FOIL this out and just verify. I've got x times 2x squared. That would give me a 2x cubed. I've got x times 5. That would give me a 5x. I got a minus 2 times a 2x squared. That's a minus 4x squared. And I got a minus 2 times a 5 gives me a minus 10. Now if I put these in order, remember this is called standard form, you go highest exponent to lowest. So I'd put the 2x cubed first, I'd put the minus 4x squared second, I'd put the 5x third, and then I'd end with the minus 10. And if you compare that to what we started with, you'd say, oh, look, perfect, perfect match. So it's always a good idea, if you ever have the least doubt in your mind whether you did it quite right, you can always FOIL to check. It takes half a minute. It's worth half a minute, because if you find you made a boo-boo, you can go back and fix it, find it and fix it. Page 1 is done. So that's the basic idea. I have shown you the basic idea of factoring by grouping. It's just that dumb. I should point out a couple of little tricky things that can happen. There's 2 tricky points in particular that we need to be aware of when we're playing with these things. And the first tricky point actually involves having a negative in the middle. Beware the negative in the middle. I'm just going to put a flag like this. It's like a red flag. Does that look like a red flag to you? I don't know what that looks like. So I'm going to make it look like a better red flag, like this. There, that's a red flag. Okay, if you have a negative in the middle, it's a red flag. Let's go through this. What could possibly go wrong? I don't know. So let's start our grouping. 7x cubed plus the 21x squared. We're going to put in a group. Here's what's different. Before, we always went like this, add. That's what we always did before. Let me back up. I'm warning you that I'm about to scroll, because I hate it when people scroll. But anyway, see, we usually had a plus in the middle. We usually had a plus in the middle. Well, now we don't have a plus in the middle. We have a minus in the middle. So this is going to be a little different, because right here I could put my 6x, but notice I cannot put minus 18 like this. I have to put plus 18. That's extremely important. Why do I have to put the plus 18 there? I have to put plus 18 there because I need this line to say the same thing as this line. And this line says minus 6x, which is okay, but now notice I have to make that a plus 18 here so that when I would distribute the negative, it would become the negative 18 that I really need. Okay, so beware of that. Come on, arrows. You can do it. Go away, go away, go away. Okay, beware of that. So the effect of this negative in the middle was, okay, I had a negative in between, but I had to change this sign. So let's just be very clear about that. Okay, there's something going on there when you've got a negative in the middle, so be very careful about that. Now, having been careful about that, I think it's safe to just keep going now. So I'm looking at the first parentheses and I'm saying, hey, I can get 7s, I can get x squareds out of both of those. That's going to leave me an x plus a 3 minus. And looking at the last two terms, I can get a 6 out of those. So I got an x plus a 3 like this. Again, I got a match. The x plus 3's, they match. I have two terms here. Notice it's two terms because, oops, it's two terms because I have blah 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 minus blah 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 blah. So terms are separated by addition or subtraction, remember? So I have two terms, and both of these terms have that yellow-greenish common factor, which means that I can pull it out to the front. So I pull the x plus 3 out to the front. Maybe I shade it in green just for effect. And then I'm left with, from the first term, I'm left with the 7x squared. And from the second term, I'm left with the minus 6. And here is my answer like this. And I invite you to maybe pause, take a minute. If you foil that out, it will indeed match. So be careful about that negative in the middle. Giving this a lot of emphasis, you really got to watch that negative in the middle. Maybe I'll zoom in on this one. How's that for an effect, huh? Okay, let's look at this one. First, same thing. We got a negative in the middle. Watch out for the negative in the middle. So I got a 5x cubed minus a 10x, that's a cubed, minus a 10x squared. Okay, I'm going to group those. I have a minus in the middle. Remember, I am not at all ever going to do anything like that ever. No. Okay? It is not a foiling problem. This is not a multiplication. This is supposed to be just a innocent little old addition of 3-4 terms together. Hey, what are you doing? Okay, there we go. So I got the minus there, and because I have the minus there, notice putting the x there, that looks okay, right? Minus x, that looks fine. But I can't just put plus 2, I have to put minus 2 here. That way minus times minus would give me a plus 2. Okay, so be very careful about that. Next line. From the first two, I can pull out a 5x squared, leaving me with a, what, an x and a minus a 2. Cool. Minus. And then you look at this x minus 2 over here, and you're like, what? I can't pull anything out of that. And this is my next, come on, you. Okay, and this is my next point that I wanted to make. You can always at least pull out a 1. I know it barely counts, but as pulling anything out really when you just pull out a 1, but you could pull out a 1. And the reason I want to do that, of course, is just to make the next step easier to see. So I do have my two common terms, an x minus 2 here and an x minus 2 here. I'm going to pull out the x minus 2, leaving behind a 5x squared from the first term and a minus 1 from the second term, just like that. And again, I would invite you to foil this out. Actually, maybe I'll just do this. I'm going to foil this out. X times 5x squared is a 5x cubed. X times a minus 1 is a minus 1x, right? Minus 2 times this is a minus 10x squared. And then a minus 2 times a minus 1 is a plus 2. If I put these, or if I put this in standard form, which means the highest exponent, then the next highest exponent, then the next highest exponent, and then the number last, I say 5x cubed minus 10x squared minus x plus 2. 5x cubed minus 10x squared minus x plus 2. It's a match. It works. Okay. So one reason to one reason to show you this factor by grouping thing is because it gives us something we can try when we run across four terms that are not combinable. Looking back at this one again, give me back my pen, would you? Okay, these four terms are not. Uh, there's no like terms there. You can't simplify this. It's four terms, unless you have this factor by grouping idea. Okay, so that's one good method, I suppose, or one good reason, I should say, to know about this factor by grouping stuff. Here's another big reason, and I'll bet a lot of you have run into this already. There's something called the AC method that you can use to factor trinomials. So I'm going to do, you'll notice I've got the same trinomial twice. Okay, I'm going to do it first, quote my way, and then quote the new way. It's not really my way, it's the old way. The old way versus the new way, the modern way, the hip way, the cool way. No, it's not cool. It's not cool at all. That's the problem. The old way is the cool way. Anyway, the old way, when you have this 2x squared minus 7x minus 9, remember what we would do. We would say, I see three terms. It's a trinomial. Somebody probably foiled something to get that. And remember that FOIL means basically this. The 2x squared came from multiplying the two first terms together. Well, what's that mean? It means I must have had a 2x times an x, right? How many ways can you make 2x squared? It must have been a 2x times an x. So that's not much of a guess, really, but here we have to guess a little bit. We have a 9, really it's a negative 9. We have a 9 here, as you have to think in terms of, okay, that 9 came from the last terms, but the 9 could have been a 1 times a 9, a 3 times a 3, or a 9 times a 1. And so you have to just kind of try these in the last positions until you get something to work. Now there's only three things to try, and I think when you get real good at this, you can kind of try in your head. Until you get there, you should really try on paper. But the whole idea is you're supposed to kind of try a combination, like maybe try the 9 there and the 1 there. I'm just trying this one. And you check your inner and your outer products, remember. So my outer product is a 2x. My inner product is a 9x. This is supposed to be, your outer inner terms are supposed to be negative 7x when you add them together. So if I got a 9x and a 2x and what I want is a negative 7x, I must have to do it this way, where I have a minus 9x and a plus 2x. So if this is minus 9x, this must be a minus 9 times an x. And if this is a plus 2x, this must be a 2x times a plus 1. And then again, you just kind of spot check, make sure the, oh man, I want more colors. I don't have enough colors here. This one, come on. Make sure that, make sure that this times this really is negative 9. And it is. Negative 9 times 1 really is negative 9. So it worked. So that wasn't so bad, was it? Guess and check. It's the old way. That's the way people used to do these things. The old way. It's a healthy way, I think. But there's another way, and it's called the AC method. And I mention this because I know a lot of you have seen this before somewhere. I know it because when I grade homework, a lot of people decide to do it this way, even after I just showed them this way. So you might as well know it, and I'm pretty sure Alex is going to do it this way too. You might as well know it. Later you could take your choice between the two, I suppose. But the idea with AC method, remember quadratic formula, we tend to say ax squared plus bx plus c. We call these coefficients, just the coefficients now, we tend to call the 2a, we tend to call the negative 7b, and we tend to call the negative 9c. Okay, so step 1 is to multiply a times c, hence the name AC method. So I got a 2 times, and I really should have been careful to make sure I was highlighting that negative 9 there. 2 times a negative 9, which is a negative 18. That's called your AC, because it's a times c. It's negative 19. That's step 1. Step 2, split negative 18, and it is important to think about the negative as well, into a pair of factors that sum add up to the b, which is a negative 7 in this case. So you have to take negative 18 and say, what is that? It's 1 times 18. It's well, it's actually negative 1 times 18, or maybe it's 1 times negative 18. Could be 2 times 9. Maybe it's negative 2 times positive 9. Maybe it's positive 2 times negative 9, and so on. And actually, I think I just hit on it right there, didn't I? So it's going to be a positive 2 times a negative 9. Positive 2 times negative 9 gives me negative 18, and when you add them, you get negative 7. So that's your magic pair. That was step 2. Step 3, use these, I'm talking about the plus 2 and the minus 9, use these to do something that's called split the middle term. Split the middle term. That says middle. Split the middle term. So our middle term was a negative 7x here. So we're going to split that into a plus 2x minus 9x. Okay. So in other words, it's going to look like this. Leave the 2x squared alone. Now the minus 7x, you can go plus 2x minus 9x. By the way, it completely doesn't matter whether you do it that way or whether you do the minus 9x and then plus the 2x. It completely doesn't matter, so you don't have to worry about the order at all. But then notice we got a minus 9 at the end, so I'll just leave it like that so I don't have to erase again. But you split the middle term. So what the heck just happened there? What we did, come on you, is we took this negative 7x and we split it up as a negative 9x and a plus 2x. Then you factor by grouping. F by G, factor by grouping. So the first 2 is going to be a 2x squared minus 9x, and then we're going to have a plus a 2x minus 9. Then from the first terms, from the first group, you know you can pull out an x at least, 2x minus 9. And then from the second group, doesn't look like you can pull out anything, but you know you can pull out a 1 at least, right? So we'll pull out the 1. And so this ends up being happy, happy. I've got 2x minus 9s in both of these. So I pull out the 2x minus 9, and then I have left behind an x plus a 1. And this ends up being your answer. And you'll notice it's a match. I got the same answer both times. That's a smile. That's not a, happy. Oh, man. I got to get better at this pencil thing, don't I? I really got to get better at this pencil thing, don't I? Yeah, okay, so there I am. That's a match. So, I don't know, which way do you like better? I suppose people that like this way better, this AC way better, what they like about it, I mean, what would you like about it? You'd like that it's a nice recipe, right? It's a step-by-step, do this, do this, do this, do this, do this, and you'll get the answer eventually. If you're liking this method, why do you like it? Well, one, it might be a little faster. If you're okay doing, playing around with some numbers in your head, and they're not big numbers, 2, 9, 18, maybe, something like that. You just play around with numbers in your head and guess and check. I like this way because I'm closer to the action. In other words, I kind of know what's going on here when I go 2x and minus 9x. I'm trying to get the outer and the inner terms to add to minus 7x. So to me, it's like I'm closer, I understand better why I'm doing what I'm doing. Whereas over here, I think this second step seems a little mysterious. I'm not sure that it's obvious right away why that should work. In fact, I know it's not obvious right away because I don't know why right away. I'd have to think about it to figure it out. Except I'm not going to because I like this way. So anyway, you can use whichever method you like. So here's the AC method for trinomials. It's based on factoring by grouping. But the other thing too is I always find factoring by grouping is a little harder for people to get. So to me, factoring by grouping comes after trinomials, not before. But whatever, I'm just yapping here, right? So you've got your lesson. So now let's look at the homework real quick. Let's see. Hey, look, I'm back. Let's look at the homework real quick. So the first page is just a whole bunch of factor by grouping stuff. The next one is, okay, I'm going to tell you right now, be careful with these two that I'm pointing at, or these two that you're looking at, because factor completely, the word completely is the hint I'm going to give you. And then you'll end with just a pair where, well, they're not quite the same, but they're almost the same. Do one by guess and check, do the other using the AC method. That way, you can practice what I just showed you in the lesson there. Okay, I think we're done. Yeah, we're done. Have a good day while I try to turn this darn thing off.